Okay, welcome to lecture number 32. In last lecture we have seen application of midpoint theorem in concurrency of medians, and before that we have seen concurrency of altitudes. In lecture 32 we will look at some geometric inequalities which are again very important in geometry as well as some other topics in 11th and 12th. First of all, we have already proved that if the triangle is isosceles, if AB is equal to AC, then opposite angles are congruent. We have seen this in congruency. We have seen this if two sides of triangle are congruent, then if and only if their opposite angles are congruent. If and only it means if I give you B is equal to C, you can prove AB is equal to AC, and if I give AB is equal to AC, you can prove B and C are congruent. But now if the sides are not equal, which is in general the case of triangles, if sides are not equal, then what do we do about the angles? Then the first theorem is in any triangle angle opposite to greater side is greater. Angle opposite to greater side is greater. So it is given that given AC is greater than AB. In this diagram we can see AC is greater than AB. So given AC is greater than AB, to prove that angle B is greater than angle C, measure of angle B must be greater than measure of angle C. This is obvious, but we need a technically correct proof in geometry. Now you are free to think on your own, find out your own proof, but if you cannot, watch this video. Okay. Now it is given AC is greater than AB, therefore AB is smaller than AC, and hence I can always plot a point D on AC such that AB is equal to AD, join BD. Now because I am aware of isosceles triangle compared to the triangle whose angles are different or sides are different, I convert the triangle into at least some part of the triangle into isosceles triangle. That is what is the strategy. So AB is equal to AD, so I got isosceles triangle over here, and hence this angle will be X, then this angle will also be X, and you see that this angle capital B is bigger than X. Let us call this small angle as W. So now what do you get out of this? We want to prove angle B is greater than angle C. So considering triangle DBC, X is an exterior angle. So we get X is equal to angle C plus W. And B is angle B is X plus W. So now if we want to compare angle B and angle C. So angle B is X plus W, and from this equation what do we get? Angle C is X minus W. So W is a positive quantity which you are adding in X to make angle B and subtracting from X to get the angle C, and therefore angle B must be greater than angle C. This is a simple angle chasing proof for the first theorem. Second would be the converse of this. If given angle B is greater than angle C, to prove that AC is greater than AB. Now, having proved first theorem, it is easy to prove the second. If we assume this as a theorem and this as a converse, then doing this is very simple by contradiction method. So if possible, let AC equals AB. If AC equals AB, we know that angle B must be equal to angle C. Contradiction because it is given that angle B is greater than angle C. So case 1, AC is equal to AB. Case 2, AC is less than AB. Now if AC is less than AB, then we have this theorem to support us by previously proved theorem. What do we get? Angle C is less than angle B. Angle C will be less than angle B. Applying this, but then the inequality here is little opposite, and therefore the result is opposite. Okay. So if AC is less than AB, then angle C is less than angle B. Contradiction, because it is given angle B is greater than angle C, and hence the only condition remains is 3. This implies 3 AC must be greater than AB. So by contradiction method, the second half of the proof is absolutely simple. However, suppose we were given this theorem first and this was a converse of this, then it is little tricky. Okay, so let us look at that consequences also, because here it was side given to us and copying side is easy, we can chase angles. But if the angle was given first, copying angle, how do we go about copying angle? Let us check that. So what we are going to do now is, given B greater than C, to prove that AC is greater than AB without using the original theorem. Okay. Now here what we need to do is, in this triangle, again we have to create isosceles triangle, but not by copying the side but by copying the angle. So it is given that angle B is greater than angle C, and therefore I can construct a line or a ray like this, such that these two angles are equal. I want these two angles to be equal, and therefore I would like to find out what angle should I make to BC so that those two angles are equal. Okay, and therefore what is the measure of this angle? It is B minus X. Okay, so the total should be B. I have removed X part of total B, therefore I get this B. Now, and what will be the measure of this angle? They must be equal. B minus X must be equal to this. But can I find out this angle in terms of C and X? Of course, yes. It should be, this angle should be C plus X, because it is exterior angle. And now I want B minus X is equal to C plus X. Therefore, what measure of angle I should do is B minus C by 2. If I draw a line with the measure B minus C by 2 angle with respect to BC, then the triangle that I will create will be isosceles, and that will give us the proof. Okay, so draw X angle here and get point D, and then because this angle X is B minus C by 2, these two angles are equal, these two angles are equal, therefore these two sides are equal, and because D is between A and C, AC is greater than AB. Hope you have understood this. We are measuring an angle which is positive from BC going inside the triangle, and it was given B is greater than C, therefore X is going to be definitely positive, B is greater than C, therefore X is a positive quantity, and hence we will get point D such that it is between A dash D dash C, implies AC is greater than AD, implies AC is greater than AB. This is the final proof. That is what was to be proved. So if the second theorem is to be proved independently, we can prove it, and if it was to be proved as a consequence of first theorem, then it is absolutely easy. Okay, so these are the two theorems in this particular lecture, lecture number 32. We have got 7 problems. They might not be related to inequalities. I can see a couple of them, but try them hard. Check whether you can solve them, else take our help. Okay, thank you. See you in the next lecture number 33.